This problem, we're going to have to look at this truss here, but now we want to figure out the forces in these two members here. So we're going to make a cut like this, just like we did last time, but just shifted down one section. And again, we'll be able to figure out what these are, but we won't be able to figure out the absolute value of these two forces in these two members, but we'll be able to figure out what the difference is. So we make the cut and we expose our forces in this horizontal member and the two forces in the vertical member. So we actually again have four unknowns, but we're only going to have three equations. Summing the forces in the x direction, in the y direction, and then the moments about this point here to give us our three equations. And again, we can see that FHI and FHG always occur, and FHI always occur as a difference. Okay, so here there's a difference, here there's a difference. We could change this around a little bit to make it a little more explicit. We could say, let's see, this is like this a minus sign, and then this a minus, and then this a plus. So we have HG, FHI minus FHG as a basically an unknown here. So if we combine those two, that gives us three equations and three unknowns. So we can solve for FKI, and it is minus 11.25 kilonewtons, and FJG is 11.25 kilonewtons. And again, we could figure out what this difference is, but we weren't asked to do that. And so we can see again, these are in tension over here, compression over here. And if we compare to the previous one, up here at higher on the structure, we have the stresses or the forces in these members are lower than they are here, because these ones have to offset these moments, the moments created by all of these wind loads. Assume that wind loads on this building. So as we go down, this one would have a lower forces, and then middle, and then the greater. So we get greater forces in each member as we go down from the top of the building.